We are tasked with finding the median of two sorted arrays. So you have two arrays, they have values in them, each of them are sorted, and we want to find the median between the two of these arrays. So in example 1, we have 1 and 3, and we have 2. We find the median between those, and we find that the median is 2 because we have 1, 2, 3, and the middle of that is 2. That's an odd length array, so we take the middle of that, and as we know, when the array is even length, we have in example 2, 1, 2, 3, and 4, in which case we add the middle two numbers and divide by 2, and that is our median. At first glance, a solution might look something like merge arrays, find median. And this is not horrible intuition. It's not bad intuition because ultimately what we're taught is we need all the information that we can get when it comes time to find a median, which is we have to sort all the information and then take the middle value if it's odd length there, or the middle two value sums divided by 2 if it's even length. But there is key tools in this problem that allow us to solve it quite optimally without needing to have access to all the information in the array, and that is that they are already sorted. So let's take a shot at this. First, we want to say r equals empty bracket, initialize a new array or list. And then what we'll want to do is set the index, set the starting index for each of these, which is I and j, 0 and 0. We want the length, okay, the length of each of these arrays, the length of each array. And the reason that we want to do this is ultimately to iterate until we have access to the middle of these two arrays, or the middle plus 1, or basically if the length is even, the last value of the left array when split down the middle, and the first value of the right array when split down the middle. And then we need to be able to mark if the array length is even or odd. And the way that's going to look is if m plus n mod 2 equals 0, we'll say even, or odd equals even. So now we know that the length of the array is even. In the event that that does not pass, it means that the array is odd. You'll see what we use this for just shortly. But ultimately that we want to be able to have a stopping point, knowing or conditioned that the length of the arrays combined are even or odd. Great. Now we need to find a way to merge these values until we have access to the middle value or the middle two values that we need to compute our median. So let's take some notes. So we want to merge values from arrays until you have, let's say, middle value, parentheses, value just in case we need 2, for median. Okay. Now let's put this in a while loop, and what that's going to look like is, remember, we want to increment I and j until we have enough access to the values that we need, ultimately the middle values between these two arrays that allow us to compute the median. So we'll say while I is less than m, and j is less than n, and j is less than n, a and b, nums 1 I and nums 2 j, nums 1 I and nums 2 j. So we have the values for those indices. And then we'll say if a is less than b, if a is less than b, I plus equals 1 r dot append a. Okay, so now we find that the value at the ith index of nums 1 is less than the value of the jth index at nums 2, which is exactly how we want to iterate across these two arrays. So we maintain that sorted order. In the event that that is not true, we have that j plus equals 1, and then r dot append b, r dot append b. Okay. There's another thing that we want to check, which is ultimately, remember what we wanted to, our stopping point is if I plus j equals, remember, m plus n over 2 over 2 plus 1. Then we break, because remember, what we're trying to do is stop at the last value for computing the median, which is either the middle value of the arrays merged or the middle two values if they are of even length combined. Okay, great. The next thing we'll want to do is remember now that if this breaks out and we still have not enough values that meets this condition, which is line 26 and 27, which is ultimately finding the value for our stopping point, we need to continue to iterate across what's left. And the way that looks like is in case, let's say in case len of nums1 is greater than len of nums2, okay, then we'll say while I is less than m, if I, so let's copy and paste that actually, if I, right, if I plus j is m plus n over 2 plus 1, remember that, we actually have iterated over the values that we need and we reach a stopping point, then we want to break. Otherwise, r.append nums1i, and then I plus equals 1. We're going to increment. And then, of course, as you can expect, in the event that that is not true and actually we've exhausted nums1, we'll want to do the same thing for nums2 and using our j iterator. So j is less than n, same exact condition here for lines 38 and 39. We have r.append nums2 j this time, and then we want to increment j because that is going to exhaust as far as we need to go, guaranteed. And now finally that we have the stopping point where we need to be, we want to, what do we want to do? We want to return the median based on if it's even or odd. If it's even or odd, right? And that is length, even or odd length, excuse me. So if even or odd equals even, okay, and I plus, and I, what do we have? I plus j equals that m plus n over 2, right, plus 1, right? That's that same conditional above. We want to return r negative 1 plus r negative 2, and that is over 2. Okay, so remember, we've gotten to the last point of values that we needed to compute our median, regardless of if it's even or odd. We just need to know, is it even or is it odd, right? And in the event that it is even, we want the last two values divided by 2, the sum of the last two values divided by 2. Else, return r minus 1. Okay, let's run this. Accepted, submit, outstanding.